last lectures, that is 1 and 2, I had talked about the philosophy of the subject, how environmental geomechanics got evolved, and what is that we are going to discuss in this course CE 641. I had given you a brief idea about what are the contents of the course and what are the reference books which you can follow, and a bit of the grading pattern and what are the prerequisites for the course and so on. In continuation to this, let me introduce the topic, and I will start with the civil engineering. Most of you are civil engineers, all of you are civil engineers. So, if you go to the copybook style of the definition of civil engineering, it tells you that our activity is to design and construct public works, and this has been coming on since long, since several years. And sometimes we also say that we are the designers and builders of the quality of life. But over the years, this definition has got changed and there is a shift, and this shift is a transformation. So, why there is a transformation? Because the society is evolving, and when the society evolves, the old concepts keep on changing over the period of time, and so has happened with civil engineering as well. It is not the same civil engineering what we used to study when we were students and what we are professing now as a professor. So, you will observe that there is a marked difference between what you used to be and what it is going to be and what it is right now. So, if you read this statement carefully, the profession revolves around the practice of improving and maintaining the built and natural environment, all right, to enhance the quality of life for present and the generations to follow. So, what comes to your mind? Why there is a shift like this? What has forced this shift to occur? So, I am sure if you read this definition again and again, you will get this feeling that things have changed, and why things have changed is what is written over here. So, civil engineering is mostly the practice of improving and maintaining the built and natural environment, all right. So, the definition of civil engineering itself includes environment into it. And when we talk about the built environment and the natural environment, what we are connoting to is the naturally given environment, like where our predecessors are living in caves, in jungles, in forest areas, and from there the transformation has occurred to the built environment, which is man-made. Is this fine? The emphasis is on improving and maintaining both the environments. It is not only the creation. Now, when you talk about the improvement and maintenance, what are the obvious things which come to your mind? What type of materials I am going to use? Number 1, what type of practices I am going to use? What type of optimization techniques I am going to use to optimize the materials which I am going to use and the type of techniques I am going to use. And this is where we also talk about the sustainability. So, sustainability term has got inbuilt over here if you read the last line. So, this is the quality of life, but keeping in view the sustainability issues, and this is what is meant by present and future generations. That means, you are talking about the improvement and maintenance of the structure which we are developing, which we are creating in a sustainable manner, all right. So, the most recent term which has got added to our profession is sustainability. So, this is what actually I am going to elaborate more in this discussion under the realm of environmental geomechanics. So, if you read again the definition of civil engineers, who are the designers and builders of the quality of life, the sustainability term was missing in the earlier definition, and that is what actually we are trying to cater to. So, this is the main emphasis from civil engineering to civil engineers, what shift has occurred in the recent past, and that is what actually environmental geomechanics would try to touch upon, how this transformation has occurred If you remember in lecture number 1 and 2, I had talked about the need or the requirement for changing the concepts of the classical subject and redefining them for our, alright. So, whatever exists cannot be applied several times. So, how we are going to change those concepts to solve the problems of the present day society in a most sustainable manner is the basic theme of environmental geomechanics. Is this part clear? So, if you look at the subject organization and what is the genesis of environmental geomechanics, this is an interesting philosophy. Basically, all of us are geotechnical engineers, civil engineers converted to geotechnical engineers, and now we are in the process of getting converted to environmental geotechnologist. So, if you look at the subject organization is geotechnical engineering, which basically deals with geomechanics, alright. And when we say geomechanics, we talk about normally rock mechanics and soil mechanics. And these are the tools, like see, rock and soil are the materials and the mechanics is the principles of physics to apply a problem by using mathematical tools. So, when you are dealing with the materials like rocks and soils and you are applying the concepts of mechanics to solve the day to day problem like foundations, retaining structure, seepage, stability, slopes, dams, these are the applications of the concepts. This is what is classical. Now, so what has happened in the past? We have been talking about only the materials, rocks and soils, without realizing the effect of environment on the material. There are several activities right now which people have identified, both naturally occurring or man-made, where rocks and soils might get affected when they come under threat of extreme climatic conditions. So, I do not know whether you are aware or not, say any country's nuclear program, see every country wants to become an atomic major, is it not? That is what you are reading in newspapers. So, where is the role of geotechnical engineers, in what way they can help the nation to become a nuclear power? So, most of the time the ore comes because of the mining, clear. We call them as the mining issues, environmental effects on mining processes, or sometimes we also call it as the influence of mining activities on the environment. So, when you start from the process of the fuel cycle, let us say, particularly for either thermal powers or for nuclear power. So, the first step there is you do mining, you take out the ore, it could be coal also which is used in the furnaces. It could be the ore which is containing nuclear activity also, clear. So, good example would be uranium, let us say. So, from the mining I get these ores, I process them, some portion of this is unused which is known as tailings, we discard them somewhere, whatever is the processed part we bring it to the industry, we use it for our purpose, and then again we produce lot of waste out of it, clear. Now, this is the catch and this is the beginning or the genesis of the subject environmental geomechanics. Now, how you are going to link it with the rock mechanics and soil mechanics? Rock mechanics gives me the concepts of the material like rocks, which are very impervious, but might be fractured also, but they are solid bodies in which I can dispose highly toxic waste material, and because of its low permeability the geo environment is not going to get affected. You agree? So, this is one situation where whatever industrial toxic waste is coming out of the industrial units can be disposed in the rocks by virtue of their extremely low porosities and extremely low permeabilities. But in the process what is going to happen? When you are dumping the waste over there which might be having chemical attributes like concentration of chemicals associated with this or very high temperatures, clear. These are the two attributes which we are interested in right now. They are going to affect the rock mass in which the waste has been disposed. This is one of the examples of what I was citing about the man-made activities which are influencing the geomaterials, all right, directly or indirectly. There could be another situation where whatever industrial waste is coming out, I might be discharging it directly in the ground, all right, superficial discharge. So, in that case what happens? The top layer of the geomaterials are soils, they might be getting interacted with the industrial pollutants or the waste which we are discharging. So, this is where the material like soil comes into the picture. In other words, what is happening is, by human activities or natural activities, the geo environment is getting affected, contaminated, influenced, and that is what I have written over here. As far as the classical concept is concerned, we do not talk about any contaminant, presence of contaminant in the system. Everything is very neat and clean. Most of your experiments you have done by using distilled water or tap water, and this type of situation is not going to occur in the field ever. The chances of studying hydraulic conductivity of a porous media which is located in the natural deposits with fresh water supply is extremely less in present day context. Why? Because too much of industrialization is occurring. So, everywhere the pollutants are being discharged either deep inside the ground or on the surface, and hence what is going to happen is, the way we used to consider the mechanics of the rocks and the soils is bound to change, because the effect of the contaminant or the human activities is going to be much more on these systems, and I cited some examples. Now, out of the two, if I consider which material is going to get affected much and why, rocks or soils? So, what is your guess? Why? So, the question is, out of soils and rocks, which one is going to get influenced because of the environmental activities more, and why?
Hello.
Yeah.
Uh, Maybe soils are more affecting things compared to rocks because they are more permeable or porous.
Well, I can always compact soils in such a way that they may become extremely impervious.
Maybe because, or maybe
I am just
chemicals.
countering your logic.
No, it's not possible all the time because the soil naturally occurring is not so compressed. So
Well, I
it's
can
not.
always compact clays to get a permeability 10 power minus 11, and for rocks 10 power minus 20 meter per second is practically same. Both are impervious.
So
All right.
dumping areas, maybe soil is not so compressed way or not in that.
Okay, this is one of the logics, correct? Yes.
Same soil will be affected more.
Apart from this, why? Give a thought. It's all about
It has
reasoning.
more surface area than rocks. So
Why? Yeah, you are right. Your answer is correct. Soils might be having more surface area than rocks. Why?
Because as particle size is smaller. So
No. What is the correct answer? Look at the matrix in which they are, bound. All the minerals in rocks are bound in a very, very compact matrix as compared to soils. You agree? Yeah, that is one of the reasons. Yes, you wanted to say something? So, my logic is, soils are the offsprings of the rocks, and the chances that the offsprings will get contaminated, adulterated, deviated are much more than their parents. You like this logic? They are kids. So, the chances are they may get more influence from the environment in which they are kept. So, your logics are also correct, but the way I am looking at the material is like a offspring of the rocks, and then I am saying this is a young material as compared to rocks. Is this okay? So, the chances are that the young material will get contaminated, adulterated are much more as compared to the parent material, and then the logic comes, porosity is less, the matrix in which the minerals are bound is extremely compact. So, if you consider the permeability of granite is extremely low. Why? Because that matrix is so hard, so compact, so intense that the minerals are not free to interact with the environment. Is this part clear? This sounds good. So, I have used lot of adjectives, I have used lot of definitions, I have used lot of words to define why this material is inert. So, the first time I am using a word inert for a geomaterial. Is this okay? And just to create a relative comparison between the rocks and the soils, I have said that the rocks are inert, but the soils are not. So, if this logic is correct, I would say that soil is a material which gets influenced by the environmental activities much more. And when this happens, we have to include whatever changes the material is undergoing when it comes in contact with the environment, fine, and how would you quantify this? And this becomes a big challenge. And that is what we say, the influence of the environment on the practice of geomechanics is going to be extremely challenging. So, what we are going to study in environmental geomechanics is, first of all, we will try to understand the fundamental properties of the soils and the rocks. What properties make them very conducive or vulnerable to the environmental impact? And once we have understood, yes, the environment is going to impact these properties more, the next question would be how to quantify this. So that once the quantification has been done, I can utilize this concept in my design practices. Is this part clear?
After quantifying, we can go for what can be the effects of the
Yeah, once quantification is done, I know how good you are as compared to me. Otherwise, it is all abstract. It is qualitative. I can't feed this data in a computer program, but the moment I have quantified a number, the moment I said this property has changed to this by this number, I can do mathematical modeling, I can do numerical modeling, I can do modeling later on. So, the big challenge is, first of all, try to understand the material, try to understand what is the influence of the environment in which it is kept, and this could be natural as well as man made. And once we have understood this, we will try to quantify how much changes the system exhibits because of this interaction. Good example of environmental influence would be, suppose you are making embankments. Now, embankments are exposed to the sunlight forever, is it not? Do you perform any tests in the laboratory to show or to exhibit how much the material is getting degraded because of the sunlight for 40 years, 50 years, 100 years? It is a quick example. So, when you make railway tracks, embankments, all right, when you make dams, they are getting exposed to the UV light from the sun. We never talked about how the material is deteriorating over a period of time. Is this part okay? Because the conventional subject does not include these effects. It is a quick example, how the material is getting deteriorated, how the material is getting upgraded because of some other activities. So, this is what actually we are trying to focus upon.
In the conventional design like embankment design, for the design life we treat the material as, even soil as inert. Like I presume that my grain size will remain same, it won't alter.
Very good. So, why failures are occurring? You are using the best possible softwares, you are using the best possible design techniques, even then the failures are occurring. So, what comes to your mind? The patient is not getting treated even after giving the best possible treatment and diagnostics. So, what is the problem?
Treatment failure can be due to like design problem also.
No, I said I am using the best possible design practices. Nowadays, the best possible design softwares are available. I can get the best possible design parameters also by doing very sophisticated instrumentation and testing, but even then failures are taking place. Why? So, are you realizing the shift? Now, at every stage I am asking you a question, why? So, she said, you know, surface soils are interacting more with the environment. My first question was why? And somebody, the rocks are not really interacting with the environment, again the question is why? So, we are going to ask lot of whys, how, when, where, so what. So, the more and more you question, what happens? The more and more answers you get. So, truly speaking, environmental geomechanics is nothing but asking more and more questions to yourself and challenging what exists in the practice.
Have you come across as any case in which you have saw that every design and every parameters were okay, but they haven't taken environment effect and something has failed?
So
Like
many buildings are failing in Bombay city and cities, Delhi, and so where everywhere in the world. Why? Why? Calcutta bridges are failing. Why? Bridges are collapsing, dams are collapsing. Why? Imagine. See, these are the questions which people are asking these days. So, whatever was done 50, 60 years back, yes, it has lived its life. We lived for 60 years, 70 years, 80 years. These structures have lived for the same time. Clear? So, the way you want to retrofit your body, rejuvenate your body, these structures also have to be rejuvenated. Is this fine? So, we will see how to do all these things. So, this is only the preface of the subject which I am talking to you about.